students, welcome in your physics class with me Shraddha Shukla. I know you all are doing good and enjoying at home, but please follow the safety rules. First thing, congratulations to all of you for being promoted to 6th class. But students, seniority brings responsibility, okay? So be responsible. Okay, students, in your daily life, you see so many objects in motion. For example, an object can roll down, or an object is sliding on the floor, or you also play with the balls, okay? Now, students, did you ever think that what is the cause behind these motion? Okay, I'll tell you. Students, also you do so many activities such as picking a thing up or pushing or pulling. So how are you able to do all these activities? Well, these things can be done only by applying a force. Okay, so I am going to discuss the topic force today. Okay. Now, students, to discuss about the force, first thing we are going to do is write down the definition of force. So, the definition of force is a push or a pull. Okay. You can either push an object or pull an object, that is, you are applying a force on that object. Okay. Now, students, try to think, when you are pushing and pulling an object, what are you actually doing? Suppose if I am throwing this ball. See, what have I done? I have actually applied a force, okay, to produce a motion in this ball. A push or a pull actually causes a change in the motion of an object. For example, here I have this ball. It is at rest right now. Now, to make it in motion, I have to push it. Okay? Now, if this ball is in motion, I have to stop it and I have to apply a force for this. Okay? So, the other definition, this is the first definition. The second definition that we can write of force is something that causes the change in the motion of an object. Okay, so it causes a change in the motion of an object. Now, students, one point that you should remember is that motion of an object cannot be produced without applying a force. That is, to produce motion, you have to apply some force. Okay, so the point to remember is motion is impossible without applying a force. You cannot move a football without hitting it or without applying a force on it. Okay. Also, you cannot stop any object without applying a force on it. So, motion is impossible without applying a force. Now, the second point that you need to remember is, if you notice, to apply a force, suppose I am applying a force on this ball, then to apply a force, there is an interaction between my hand and this ball. See, if I am applying a force on this ball, I am trying to push it, okay, so there is an interaction between my hand and this ball. Okay, so the next point you need to remember is, for applying a force, an interaction between two objects or an object and its environment is necessary. Okay, so students, so for applying a force, an interaction between two objects or an object and its environment is necessary. How? Suppose you are playing cricket. What you actually do? The bowler throws the ball by using his hand like this, and the batsman, he hits the ball by using the bat. Okay, so there is an interaction between the hand of the bowler and the ball, and then there is an interaction between the bat and the ball. Okay, so these 2 points are very important to remember. Now students, there are certain effects of force. Okay, the force can affect a body in many ways. So let's discuss the effect of force. Okay, before discussing the next topic, let me tell you, I can redefine force again as force is an interaction between two bodies. It is actually an interaction between two bodies. Okay, you can redefine force like this. Okay, now let's discuss its effect. Effects of force. Number 1, the force can move or tend to move an object. Okay, so the first point is it can move or tend to move an object. Okay, for example, when you play football, you hit the ball with your legs. Okay, without applying a force, the movement of the ball is not possible. Hence, for the motion of football, you are applying a force. So what is the effect of force? It can move an object or it can tend to move an object. Okay, now second point, it can stop or tend to stop an object. Now students, have you ever seen a superhero movie? Okay, in that, whenever a plane crashes, an aircraft crashes, what does the superhero do? He holds the front area of that aircraft and then try to push it back. Okay, in this way. Although I'm not so good at drawings. Okay, so I'm just going to draw this stickman. So he is holding the aircraft. The aircraft is coming in this direction in a very high speed, and the Superman tries to push the aircraft in the opposite direction with almost equal force, and gradually he is successful in doing that, in stopping the aircraft. So the force can stop or tend to stop an object. Okay, suppose this ball is in motion and I have to stop it. What I'm going to do? I'm going to apply an opposite force on this ball like this. Okay, if I am unable to apply the equal force, the ball will not stop. Okay, so it can stop or tend to stop an object. Now let's discuss the third point. It can change the speed of an object. Now it can also increase and decrease. So either increase or decrease the speed. Now, suppose students, a ball is moving very slowly, okay, and you hit the ball with so much force, its speed increases. Okay, for example, let me take an example. Cycling. You have a paddle in your cycle like this. As I told you, I'm not so good at art. Okay, so you have paddles like this. You apply a force in this direction. Okay, although the cycle is already moving, but if you want the speed to increase, you have to push this paddle with so much force, okay, so that the cycle, the speed of the cycle is increased. Okay, now if you need to stop it, or decrease the speed, what are you going to do? You are going to push the brakes now. Okay, so the force can change the speed of an object. Either it can increase or decrease the speed of that object. Okay, if you are pushing the paddles, you are increasing the speed, and if you are pushing the brakes, you are decreasing the speed of that object. Basically, you are applying a force on paddle and also on the brakes. Okay, now fourth point, students, it can change the direction of motion of an object. Okay, so it can change the direction of motion of an object. I'll show you how. Students, in the cricket, a bowler throws the ball. Suppose this is the ball, and here is the batsman with a bat in his hand. Okay, so he throws the ball towards the batsman. Okay, now what does the batsman do? He pushed the ball towards the boundary. Suppose this is the boundary somewhere, so he pushed the ball towards the boundary like this. He is applying a force on the ball using his bat towards the boundary. So what is he doing? He is actually changing the direction of the ball. How? The bowler throws the ball towards the batsman, but what is the batsman doing? He is throwing the ball towards the boundary. So the direction of the ball is changing from this side to this side. Okay, so a force can change the direction of motion of an object. Okay, now the fifth point. The fifth point is it can change the shape of an object. This property of force you can actually see by doing practical experiments at your home. I have this soft toy with me. So now I'm going to apply a force on this. Can you see the shape of this soft toy? Okay, now I'm going to apply a force on this. Okay, what I'm doing actually, I'm applying a force, and now the shape has been changed. Okay, although it's a soft toy, so its shape cannot be changed permanently. So that was just an example. Okay, so it can change the shape of an object. So these are the 5 effects of force. Okay, now the next thing that we are going to discuss, students, that is really important, but we are going to study it using a joke. I'm going to tell you a joke, but let's start just. Okay, so students, I have 4 persons. Okay, A, B, C and D, and these 4 people are equal in strength. Okay, they have the same power, they have the same efficiency in their body to push anything. Okay, suppose for A is applying a force on an object FA, B can apply a force on an object FB, C can apply a force on an object FC, and D can apply a force on an object, that is FD. Now as I told you, all these forces are equal. Okay, FA is equal to FB, which is equals to FC, and this is equals to FD. Now the joke starts here. Here's a car. Okay, there's a car. As I told you, I'm not so good at drawing. Okay, we have a car which is stuck in the mud. Now what are you going to do? Actually, we are not going to do anything. These 4 persons are going to do. Okay, so these 4 people are pushing this car. Okay, they are pushing this car, but the car hasn't moved even a single inch. Why? Try to think. Why is it not moving? All 4 of them are pushing it together. It is because 2 of them are pushing it on this side and 2 of them are pushing it from this side. Okay, that is why, since their force is equal on both the sides, so no change in the state of this object. Okay, suppose A and B are on this side, C and D are on this side. So what is the total force on side 1? Well, because these forces are in same direction, so these forces can be added. That is, force on side 1 is FA plus FB. But why am I writing this? It is because the force on same side adds up. Okay, this is the property of the force. The force on same side adds up. Okay, now similarly with FC and FD, the force on side 2, I can write it here, side 2, FC plus FD. The total force is FC and FD. Now students, try to think, what is the total force being applied on this object or on this car? What should it be? If I am saying that the force on same side adds up, then what should happen with the force on the opposite sides? Well, the force on the opposite sides should subtract it. Okay, so the force on the different sides are subtracted. So the other property, first property I am going to write here, force on same side adds up, and the second point is force on the opposite sides subtract, are subtracted. Okay, now let's talk about the total force being applied on this body. Well, the total force applied on this body will be, or you can say the net force. Okay, so the total force or the net force applied on this body is the difference between the force on this side and this side. Okay, difference of forces applied on both sides. Okay, so if the total force on side 1, that is F1, is FA plus FB, and total force on side 2, this is side 2, is F2 is equals to FC plus FD, then the net force, that is Fn, is F1 minus F2. Okay, so the total force is the difference between the forces applied on both the sides. Okay, now let's take an example with numerals. Suppose Fa, as the strength of all 4 of them is equal, so Fa equals to Fb equals to Fc equals to Fd, and let's take a numeral unit 2. Okay, so suppose Fa is equal to 2 units. Now 2 is applied being here, 2 unit force is applied here, 2 unit force is applied here and 2 unit force is being applied on that side. So let's solve it. The force on side 1, that is F1 equals to 2 plus 2 equals to 4. Okay, and the force on side 2, that is F2 equals to 2 plus 2 equals to 4. Now the net force, total force acting on this car, that is F net. F net equals to F1 minus F2, that is 4 minus 4 equals to 0. And that is why the car is not moving. Okay. Now please remember, students, if the force is unbalanced, suppose the person A, he changes his mind and try to support C and D. He comes here and now he is pushing the car from this side. Then the force on side 1, that is F1 equals to 2 unit. Okay, but now the force on side 2 is 2 plus 2 plus 2, that is 6. Now what is the net force? Fn equals to, this should be 6 minus 2. Okay, or this is actually comes with the sign also. So I'll tell you, you can take 2 minus 6. So this would be minus 4. Okay, now what is this sign showing? Well, it is actually denoting the direction of motion. Okay, the direction of motion. The force F1 is being applied on this side and force F2 is being applied on this side. So this is a negative direction in comparison to this one, and that is why here is a negative sign. Okay, now see the second force, that is the force on side 2, it is dominating, and that is why the car will move in the direction of force on side 2 or in the direction of force F2, and that is why this negative sign is here. So please remember, the car will move in the direction of the force that is larger. Okay. Okay, students, I'm going to end this lecture here. In the next topic, we are going to discuss about the effects of force on mass, on the speed, in the direction, and we are going to discuss about the frictional force. Okay, till then, stay home, stay safe.